Observe this sequence of overlapping browser windows, terminal error logs, and mismatched chat interfaces. This represents the exact moment a multi-agent system suffers from rapid, compounding cognitive amnesia. The failure point lies outside the AI models. The breakdown occurs because operators manage advanced agents using traditional flat-file operating systems designed for human manual labor, not autonomous orchestration. Relying on disconnected browser tabs and static API keys fragments the operational state of a swarm into isolated silos. During long sessions, this fragmented state causes a total breakdown. Agents lose the operational thread, drop critical context, and begin to hallucinate their outputs. To maintain stability, fragmented elements must be pulled into a single, organized array. Continuous orchestration requires rebuilding the operating system from the metal up. This spatial AI operating system is engineered for real-time telemetry and state synchronization instead of manual file management. We built this proprietary architecture to bypass the orchestration bottleneck. This is Orbital Os. The system operates on 3 defined pillars: a hybrid compute topology, a continuous memory ledger, and a spatial presentation layer. Preventing autonomous swarms from collapsing under context loss requires a single sovereign infrastructure spine that unites hardware, memory, and interface into one continuous environment. Sovereign AI requires hardware-level control over exactly where and how data is processed. This is the physical base of the Orbital Os tech stack: a localized edge compute node, a Mac Mini Studio, designated as Landsat. Edge compute alone cannot support heavy reasoning tasks. Operating at this scale requires a dynamic connection to public-facing cloud APIs to handle intensive compute loads. This routing schematic details the hybrid compute architecture. Complex reasoning without sensitive data is pushed down the external pathway via GCP Cloud Run. Highly sensitive data shifts the flow locally, routed entirely down the internal pathway into an isolated Ollama node on the Landsat hardware. Orbital Os evaluates task sensitivity parameters and toggles between these two states in milliseconds, requiring 0 manual input from the operator. Localizing critical tasks at the edge reduces orchestration latency compared to routing every prompt through an external server. True agentic sovereignty is achieved through an intelligent routing layer that optimizes for both data security and raw computational power instantly. Hardware routing is only effective if the autonomous agents maintain their operational memory across multi-step tasks. Increasing a model's token limit addresses single session memory, but it fails to prevent long-term agent amnesia. Token limits do not account for state orchestration across disparate applications over time. Multi-agent swarms require extreme accuracy over hours of continuous execution. To maintain that operational state, Orbital Os uses the Continuous Context Protocol, or CCP. The CCP acts as an active synchronization ledger. Unstructured data from local directories and browsers streams into a funnel, converting into standardized vector nodes in a 3D space. These nodes dynamically cluster around a focal point, representing the operator's active natural language query. These dense clusters are packaged into unified context packets. The operating system injects these packets into the active subagents, ensuring the same operational context is preserved across every node in the swarm. By fusing fragmented environmental data into a mathematical ledger, the CCP provides the persistent state required for complex multi-stage orchestrations. Moving up from the memory infrastructure, the final challenge is the human interface. An operator must direct this swarm without becoming overwhelmed by telemetry. This is the presentation layer of Orbital Os, an industrial minimalist dashboard we refer to as the Gundam cockpit. It abandons traditional windowed formats for a spatial arrangement engineered for high-speed telemetry readouts. The interface provides a unified view, visualizing both the underlying hybrid hardware routing and the active vector memory clusters. Within this cockpit, the operator commands 3 distinct subagents: the janitor, the librarian, and the daemon. The janitor agent handles systemic hygiene, running state cleanup to ensure memory channels are not clogged with obsolete data. The librarian manages the ledger, indexing Postgres vector clusters so the correct operational context is available for immediate retrieval. The daemon executes the background orchestration tasks assigned by the operator. This spatial interface lets the operator direct all 3 agents simultaneously. They function as synchronized instruments responding to a single prompt, avoiding isolated chat windows. The spatial design of the UI manages the operator's cognitive load, bridging the human mind and the sovereign backend. The macro impact of this architecture extends beyond the individual operator's dashboard. This diagram maps the broader ecosystem. Orbital OS functions as the operational kernel powering an entire venture studio, with telemetry pipelines branching to 6 portfolio companies. All 6 portfolio companies rely on the same hybrid routing and continuous context ledger to run their autonomous operations. Securing data sovereignty via dynamic edge-to-cloud hardware routing establishes the physical baseline for these companies. The continuous context ledger provides the memory layer required to support multi-agent swarms without context degradation. And the spatial orchestration cockpit allows one human to manage these complex systems without cognitive overload. Combining these 3 layers re-architects how human operators command artificial intelligence. This 3-layered architecture constitutes the foundational sovereign intellectual property of the studio. Technical architects can verify these state management capabilities by interacting with the underlying protocol at this address. Mastering autonomous agents begins by discarding outdated operating systems and building on sovereign, context-aware metal.